with this demo here, what I want to show is I've got the acid in here, and it's hydrochloric acid, and I've got a flashlight, actually my cell phone, hooked up next to it, and I'm recording data on the screen back here showing how the pH doesn't change. And I actually have a very strong acid in here, hydrochloric acid, and the pH isn't changing because I'm not adding any of the base. So I'm going to cause it to be a steady flow so we can actually see the change in the pH. So I'm going to start adding the base, or sodium hydroxide here. And actually I'll place an indicator in there so that you may be able to see the change. So I'll drop a few drops of phenolphthalein in there. Okay, and initially it doesn't change because the pH is still well below 7. But as we start to collect or add more hydrochloric acid, add more sodium hydroxide to the solution, you can notice that the pH is starting to change by a little bit. Not a whole lot, but ever so gradually, because again, I placed 50 milliliters of hydrochloric acid in the beaker, and adding the base is at a rather slow rate compared to how much I actually have. However, the pH is starting to change a little bit, and you can see that gradual incline, and I think it's making points every so often here. But as I keep that flow steady, and I'm not sure if you can notice on the camera here that there's starting to be a pink starting to form there. You may not be able to see that, but I'll give another view where you can see that. But what I want you to notice is we're already about 100 seconds in, and I didn't start it exactly at 0, but the pH is still relatively low because again, the sodium hydroxide that we're adding isn't as much as the actual base that we have. Now you can really start to see a nice pink color here if you are able to see that on the screen. Okay. Now we notice that the pH is starting to increase, even though we're not to 1 yet, but it's getting very, very close. So that makes it kind of impressive. And again, we see that steady increase as the base is added. Takes a while for it to catch up there, but now you can really start to see that pink, and we're approaching a pH of 1. And now it's really starting to take off and starting to spike, and we're going to see that quick spike here as we get well past our equivalence point here. So this is actually a pretty nice titration curve as we start to gather the data and the hydroxide is added to the hydrochloric acid. You see that big jump, and then finally the pH has jumped to a pH of 13.48, and so it's steadily approaching a pH of 14. Now if I discontinue this, okay, the pH will continue to climb, and eventually it'll get to 14 after the pH meter catches up with it. But this is a pretty nice titration curve, and I'll let that run for a little bit longer here. Pretty nice little titration curve that we have there. So, and again, when we look at this, let me identify some of the points along here. Starting off way low, and actually we're below a pH of 1 at this point right here. As we start to add more and more of the hydroxide, it slowly changes its pH because again, there's so much hydrogen ions present in the solution that any hydroxide that we add to it quickly associates with it and forms water, until we just put so much in there that the hydrogen ions that are in the solution can no longer handle that, and then it just elevates so quickly. And again, from here to here is a matter of probably 2 or 3 drops, and then once we get to that point there, it levels off nicely. And I'm going to use hydrochloric acid and sodium hydroxide today for this demo, and I'm going to add about 35 milliliters of hydrochloric acid, which is a strong acid, so that means that its hydrogens dissociate very, very well, or very easily. So let's go ahead and put that there. So there's 25. Okay. And the reason why I want to add so much is so that the magnetic stir is completely covered. And so let's go ahead and start stirring that. And I'm going to add an indicator because the base that we're using here looks exactly like the acid, and there's no way we're going to be able to know when we're at the equivalence point or the end point. So I'm going to add some phenolphthalein in here. That's a good indicator, and it has a pretty nice color. So get that mixing a little bit, and then I'm going to start adding the base. And initially, since we have so much hydrochloric acid in the solution, I want to just kind of really move it in there quickly. And we don't notice anything changing immediately. The camera can see what we're seeing. And I'm not sure if the camera can see it or if you can see it in the audience. I'll kind of fold this up so you can see the white, or have a white background here. But there's a slight pinkish color that's actually in the solution right now where the base is hitting the hydrochloric acid, because this indicator helps to indicate when we're at a basic pH. And if I turn that off, the pink goes away. Turn it back on, it shows up. So if I go little by little, it starts to, you start to see that pink a little more often. So if I kind of let it go, and again, the reason why it goes away so quickly is because there's so much hydrogen ions that are possible to react with the hydroxide, and it causes that indicator to go back to neutral or not show up. Kind of pink swirl is staying in play there a little bit longer. If I turn the magnetic stir up, it really goes away a lot quicker, more quickly. But you can definitely see it there, and as soon as I turn that off, it goes away. So if we go drop-wise here, maybe just kind of slow it down a little bit. There's a drop. And that's what's nice about this burette, that we can really watch how much we can put in at a time, but you can definitely see how the solution doesn't have as much hydrogen as it initially did. We didn't see that much pink at the beginning. So now it's really starting to appear and stay pink a lot longer than before. And again, when you're doing an actual titration, you would never go this slow, but for your first one, this is pretty cool to look at. Question: as we add the base, you can see it turning pink. What would happen if I added distilled water? Okay, would it turn pink, or would nothing happen? I hope you said nothing happened, because again, distilled water has a pH of 7, and also it has the same number of hydrogen ions as it does hydroxide, so that's not something that would cause the pH to change by any great amount. So you can definitely see it staying in pink a little bit longer now. I give it a quick burst here. Okay, increase the drop rate. Okay, see how that pink is there, and then it goes away. So now we're getting pretty close. Boom. Kind of a quick drop sequence here, not too fast. Allow it to go away. And another drop here. And the nice thing about the burette is you can add it drop by drop. There we go. We'll put it at a nice slow drip rate. Boom. And you can see that pink definitely show up now and then disappear. It's pretty cool. That one stayed a lot longer. There, it's starting to take a little bit longer to disappear on us. There, that one. And when it stays pink, then we're at the equivalence point for this indicator. It's staying a lot longer now. one's getting really close. That might do it. Okay, we added that second drop in there, and that one might get dispensed. Alright, so maybe it's one more drop and we're there. Maybe. Boom. And that one drop made a difference. Okay, and it looks like it's staying kind of pinkish there. It's pretty good. I'd say one more drop. Actually, I'm just gonna there we go, put that base in there. Now if I put a few more drops in there, it gets a little darker, but that's about as dark as it's gonna get right there. Alright, so here's my graduated cylinder that I used to pour in the hydrochloric acid initially. What I'm going to do is I'm going to take some distilled water and kind of rinse this out a little bit. Now again, it doesn't matter how much water I get in there, but here's a good question for you. What's going to happen when I pour this water into our beaker here that's at our equivalence point, or just a little bit above? Hopefully you said it would go clear, and it does. Okay, so even though there wasn't any hydrochloric acid in there, it's just some residue from the graduated cylinder. It was enough to get us to be clear again. Now, it won't take too many drops here because, again, it was just the residue that was along the sides of the container. And that's one reason why we always want to rinse out our equipment before. That was one drop. That was one drop of the base. And we're now back. Okay, I don't think... Now, I didn't hit it high up here, but let's try to hit the container high. There we go. So there was a little bit more residue in there. Maybe one more drop. And it's back. Actually, 2 drops fell in there. That's why it's so dark. Isn't that pretty cool? That is a titration. Again, this is a strong acid being titrated by a strong base.